Hello guys, welcome back to my YouTube channel. So our topic for today is hypothesis testing with population proportion. Okay, so this is the formula wherein we're going to find the z-statistic according to the hypothesis testing with population proportion. So p hat is the sample proportion while p sub 0 is the population proportion while n is the sample size. Okay, so in this numerator, all we have to do is we're going to subtract the sample proportion with the population proportion. For the denominator, this is a step-by-step process. Okay, so we're going to multiply the population proportion with the difference between 1 and the population proportion. After multiplying them together, we're going to divide with the sample size and we're going to find the square root of the quotient. Okay, so after this, we're going to divide the numerator with the denominator. Okay, so our first problem states that it is claimed that 60% of the population consisting of citizens who have been vaccinated against COVID-19. The barangay captain have found out that 320 out of 500 citizens have been vaccinated. Is there any evidence that the population proportion is greater than 60 with a significant level of 99%? Okay, so this is the confidence level. Okay, so this 99% will be 0.01. So this 99% is really the confidence level. However, we have decided to subtract with 100 with 99%. So which leads to 1%, also known as 0.01. Okay, so now we have stated the significant level. Okay, so our step 1 is p sub 0 is equal to 0.60, or p sub 0 is less than or equal to 0.60. Okay, so this is according to the null hypothesis. For the alternative hypothesis, okay, for the alternative hypothesis, okay, so we can tell that our p sub 0 is greater than 0.60. Okay, so for the step 2, we can state a given. So first, the significant level, then our sample size is 500, then our sample proportion is 320 divided by 500, which is 0.64. Then our p sub 0 is 0.60. Then 1 minus p sub 0 is 1 minus 0.60, which is 0.40. So now we have stated all the given here. Okay, so we need to identify if it's one-tailed or two-tailed. Since there is a there is a distinct or specific comparison which is greater than, we can indicate that this is one-tailed test. Okay, so in terms of the graphing or the graphical representation of the normal curve, we so the right side is the rejection region. Okay, so this is a right-hand test since the alternative hypothesis states that the population proportion is greater than 0.60. So now we're going to identify the critical region. Okay, so what are we going to do is we're going to subtract the 0.5000, the half of the area of the normal curve, with 0.0100. So it will become 0.4900. So the 0.4900 will be here. So we're going to find here. So this will be 2.33. So bale, isasubtract na natin yung half of the area sa significant level mismo ng diretso para makahanap po tayo ng area. Dahil one-tailed test to, ito, okay, so our critical value according to the significant level is 2.33. So positive siya because it is greater than. Okay, for the step 4, okay, so revisiting the formula. Okay, so what are we going to do first is we're going to subtract the sample proportion with the population proportion. So I'm going to label the given. Okay, so what are we going to do is we're going to multiply 0.60 times 0.40, since 1 minus 0.60 is 0.40, then divided by 500. Okay, so what are we going to do is to find the difference of the numerators. Okay, so we're going to find the product of 0.60 with 0.40. So what are we going to do here is zero point 0.6 times zero point 0.4 is 0.24 divided by 500. Okay, so inside the square root, okay, so what are we going to do is to find the quotient first before finding the square root. So it is 0.00048. Okay, so now we're going to divide it directly with the square root. Okay, so we're going to use our scientific calculator. So we will not be confused in rounding up. Okay, so it is 0.577. If we round it up, it will become 0.58. Okay, so I'm gonna erase my mistake. Okay. Okay, so this is the test statistic. Okay, so based on the normal curve, which is here, this is 2.33. Okay, so according to the step 4, our z statistic is 0.58. So since this is not located in the black region, okay, so we have to claim that we have to accept the null hypothesis. So our step 6 is there is no evidence that P sub 0 is greater than 0.60. So it means to say that there's no significant difference between the given proportions. Okay, so for the second example, okay, the restaurant manager have assumed that 84% of the customers are satisfied with the services of the restaurant. However, there is a report indicating that there are 280 out of 400 customers have shown their satisfaction with its service. Is there evidence to claim that the population proportion is less than 84% with a significance level of 0.05? So we can tell that this is the population proportion since there is no given population size usually. So we can tell that this is the population proportion. Okay, so we already have our p sub 0 and we already have our significant level. Okay, so our step 1 is p sub 0 is equal to 0.84 according to the null hypothesis. Then according to alternative hypothesis, p sub 0 is less than 0.84. So in determining the null hypothesis, we can also tell that our p sub 0 is greater than or equal to 0.84. Okay, so our step 2 is we're going to identify the significant level, which is 0.05. Then our population proportion is 0.84. Then the 1 minus p sub 0 is 0.16. Then our p hat, also known as the sample proportion, is 280 divided by 400. Okay, so to get the sample proportion, we're going to divide the indicated number of actual customers who have shown their satisfaction with the services with the sample size. So the 400 is the sample size. Okay, so dividing, it will become 0.70. Okay, so our step 3, okay, so our step 3 indicates that this is a one-tailed test. Okay, so what are we going to do is we are going to find the area. Okay, so the area by subtracting with 0.500 with 0.0500. So the difference between those two is 0.4500. Okay, so now we're going to use the Z table, okay, to locate the area which is close to 4,500. Okay, so safely speaking that this is closest to 0.4500, we can tell that the Z table, the critical value is, okay, so it's 1.65, or can we indicate that is 1.645 since equal lang ang gap ng 1.64 at 1.65. So, this is 1.645. So, however, since this is less than, then it is a negative. Bakit 1.645 siya? Kasi, di ba 0.4945 plus 0. Oops, 0.4495 pala, 4495, oops, plus 0.4505, then divided by 2. So it will be 0.9000 with 2 will be 0.45. Okay, so corresponding to these areas, it will become 1.64 plus 1.65 divided by 2, which is 1.645 siya. So this is the midpoint between 1.64 and 1.65. That's why our critical value is negative 1.645. Why negative? It's because it is a left tail test. Okay, so we're going to construct this curve. Okay, so this is negative 1.645. Okay, so we're going to compute the step 4. Okay, our Z table, or shall I say the Z test statistic. Okay, so what are we going to do is we're going to subtract the sample proportion with the population proportion. Then we're going to simplify what's inside the square root. Okay, so 0.70 minus 0.84 divided by 0.84 times 0.16 divided by 400. Okay, so now we're going to find the difference. Okay, so now we're going to simplify step by step. Okay, so 0.84 times 0.16 is 0.1344 divided by 400. Okay, so now what are we going to do is we're going to divide it po. Okay, so this is the square root of 0.000336. Okay, so now we're going to use the scientific calculator. So we will no longer have a hard time computing. Okay, so since this is a long process, okay, so what are we going to do is divide or simplify. So, tada, our test statistic is negative 7.64. Okay, so since this is less than this critical value, we can tell that we reject the null hypothesis since the Z statistic is in the rejection region. Okay, so for the step 6, we can tell that there is evidence that P sub 0 is less than 0.84. So napapansin nyo, kapag super layo ang sample proportion na mas mababa sa population proportion, then malamang we can reject the null hypothesis if the alternative hypothesis indicates that the population proportion is less than the indicated value. Pero kapag close siya, kung magkadikit lang sila, hindi natin masasabi kung accept or reject. So, depende sa ikakalabas nyon. So, in this case, sigurado na tayo magre-reject ng null hypothesis. It's because the Z statistic is way lower than the critical value. And the sample proportion is way lower than the population proportion. So, this applies to the right tail. So, dito naman kasi, kaya we accept the null hypothesis kasi yung Z statistic niya, this is lower than the indicated critical value since the alternative hypothesis has indicated that the P sub 0 is greater than 0.60. So, magkalapit kasi yan si sample proportion at si population proportion. So, para sigurado na magre-reject po tayo ng null hypothesis based on the right tail test, okay, so the sample proportion must be way, way, way bigger than the population proportion. So, the difference must be huge to identify that we can reject the null hypothesis. Kaya tayo nag-accept kasi mababa ang Z statistic. So, why do we need to still use the normal curve and the rejection region so we can be able to use it visually in order to accept or reject the null hypothesis? Okay, so this one. So, okay, so we're going to do the same step, yung dating gawi. Okay, same routine actually. So our P sub 0 is equal to 0.75, then our P sub 0 is not equal to 0.75. So our significance level is 0.10. Okay, so since there is no specific comparison, we can indicate that this is two-tailed. Okay, for step 2, okay, so significant level is 0.10, while the sample size is 250, then the sample proportion is 230 divided by 250, so it will become 0.92. Then our P sub 0 is 0.75, then our 1 minus P sub 0 is 0.25. Okay, so since this is a two-tailed test, indeed, there are two critical regions or rejection regions. Okay, so our step 3 is alpha. The alpha is 0.10, so all we have to do is we're going to divide it by 2 since this is a two-tailed test, so it will become 0.05. So based on the Z table, okay, so but before basing on it, what are we going to do is 1 minus 0.5, okay, 0.5 minus 0.05, which is 0.4500. Okay, so our critical value is plus minus 1.645. Okay, so we can label this normal curve along with its rejection regions. Why plus minus siya? It's all because it's a two-tailed. There is no specific comparison. So, in the step 4, okay, so in the step 4, what are we going to do is do the same thing So our p hat is 0.92, while our p sub 0 is 0, 0.75. Then what are we going to do is we're going to multiply with 0.75 with 0.25, then divided by 250. So finding the difference, it will become 0.17. Then finding the product of the proportions, okay, so it will become 0.75 with 0.25, it will become 0.1875 divided by 250. Okay, so dividing po, okay, so it will be 0.00075. Okay, so now we're going to divide, okay, so 0.17 divided by square root of 0.00075, so it will become 6.2075 or 6.21. Okay, so before deciding, we need to compare it with the critical values. Okay, so we're going back to the critical region. Okay, so since 6.21 is higher than 1.645, we can tell that we're going to reject the null hypothesis. Okay, so this is 6.21. Okay, so pasok siya sa rejection region. So we can interpret, so there is evidence that our p sub 0 is not equal to 0.75. So like what I had told, okay, so in order to reject the null hypothesis, whether two-tailed or right-tailed, yung sample proportion na yan, dapat mas malaki siya sa population proportion ng malayong malayo. Like 0.92 with 0.75, since this gap was really wide, or this gap is really wide, so it is kindly obvious that the null hypothesis has been rejected because the z statistic is way bigger than the critical value. So do not forget to subscribe my YouTube channel and hit the notification bell and stay tuned for more videos. So thank you and God bless and have a great day. Happy learning and stay safe.